Picture this. It's 1982, and a beat-up Pontiac Trans Am pulls up to the staging lanes at Orange County International Raceway. The car looks stock, sounds stock. The guy driving it is wearing a GM Service Department shirt. He lines up against a Camaro running a $2,000 MSD ignition system. Billet distributor, the works. The flag drops. The Trans Am launches like it's been shot from a cannon and wins by 3 car lengths. Same thing happens the next week, and the week after that. Racers started tearing the Trans Am apart in the pits, trying to figure out what expensive ignition system this guy was running. Turns out he wasn't. He was running a stone stock GMHEI distributor with a $12 modification that a Pontiac engineer had figured out in his garage. And that modification was about to embarrass every expensive ignition company in America. Chapter 1. The Ignition Crisis of the Early 80s. Let's rewind to the early 1980s. The automotive world was in crisis mode again. The EPA had been tightening emission standards every year since the Clean Air Act. Compression ratios had dropped from 11:1 down to 8:1. Camshafts had gone from aggressive to comatose. But the real problem, the thing that was driving mechanics and hot rodders absolutely insane, was ignition timing. See, here's what most people don't understand about late 70s and early 80s cars. It wasn't just that the engines were strangled by emissions equipment. It's that the ignition systems were fundamentally broken. Detroit had spent decades perfecting mechanical and vacuum advanced distributors. They worked pretty well. Then the EPA came along and demanded engines run leaner, cleaner, with more precise timing control. So, what did Detroit do? They added computers, sensors, solenoids, vacuum switches, and more wiring than a telephone switchboard. The result was ignition systems so complex that even dealership mechanics couldn't diagnose them, and they failed constantly. A typical 1980 GM car had something called computer command control. Sounds impressive, right? It was garbage. The system used a primitive computer that would adjust timing based on inputs from coolant temperature, manifold vacuum, throttle position, and about 6 other sensors. Any one of those sensors fails and your timing goes haywire. Your engine runs like trash, and they failed all the time. Oxygen sensors would die, vacuum lines would crack, connectors would corrode. You'd take your car to the dealer and they'd throw parts at it until something worked. Maybe. The aftermarket saw an opportunity. Companies like MSD, Mallory, and Excel started selling high-performance ignition systems. These things were supposed to be the answer to everything. Multiple spark discharge, higher voltage, adjustable rev limiters, the whole 9 yards. The problem was, they cost a fortune. An MSD6AL system in 1982 ran about $500. A complete MSD setup with distributor, coil, wires, and box could easily hit $2,000. That's over $6,000 in today's money for an ignition system. And here's the kicker. They didn't really work that much better than stock. Oh sure, they made bigger sparks, they looked impressive on an oscilloscope, but in terms of actual power gains on a street engine, maybe 5 to 10 horsepower, maybe. For $2,000, you could get the same gains by installing a better carburetor or headers. But the marketing was brilliant. These companies convinced everyone that electronic ignition was the future, that mechanical distributors were obsolete dinosaurs, and that if you wanted real performance, you needed to spend real money. Chapter 2. What everyone was trying to fix. What everyone was actually trying to fix was the distributor advance curve. Let me explain this because it's crucial to understanding why McFarland's modification was so revolutionary. In any internal combustion engine, you need to ignite the fuel-air mixture before the piston reaches top dead center. This is called ignition advance. The faster the engine spins, the more advance you need, because the piston is moving faster. At idle, you might need 10 degrees of advance. At 5,000 RPM, you might need 36 degrees. Think of it like throwing a football to a moving receiver. The faster he's running, the further ahead you need to throw. Old distributors had 2 systems for this. Mechanical advance used springs and weights. As the distributor shaft spun faster, Centrifugal force would swing the weights outward, advancing the timing. It was pure physics. No computers, no sensors. Vacuum advance used engine vacuum to pull a diaphragm that also advanced timing under light load conditions like highway cruising. Simple, elegant, and it worked. Sort of. The problem was that GM, Ford, and Chrysler had to calibrate these curves for three things: emissions, fuel economy, and performance. And guess which one came last? Every single time, stock distributor curves were compromised garbage engineered by committee. They'd advance too slowly at low RPM, meaning your engine was fighting itself trying to accelerate from a stoplight. You'd mash the throttle and get nothing but a wheeze because the timing was still at 15 degrees when it should have been at 28. They'd advance too quickly at mid-range, causing detonation and ping under load. You'd try to pass someone on the highway and hear that lovely engine-destroying rattle, and they'd top out too early at high RPM, leaving power on the table right when you needed it most. Every stock GM distributor from the late 70s and early 80s had these problems. Every single one. It wasn't incompetence. Detroit's engineers knew how to build proper advanced curves. They'd been doing it for decades, but the EPA had them by the throat. To pass emissions tests, they needed timing curves that would barely let the engine run. Lean mixtures, retarded timing, everything optimized for the test cycle, nothing optimized for actual driving. The result was engines that felt gutless, got worse fuel economy than they should have, and wore out faster because combustion was terrible. Hot rodders knew this. They could feel it every time they tried to merge onto a highway. So they'd buy expensive adjustable distributors where you could swap springs and change advanced curves. Companies like Mallory and Axle sold these for $300 to $500. Or they'd go full electronic with programmable timing curves. Boxes full of electronics, complicated wiring, tuning software. Both solutions cost hundreds or thousands of dollars. Both were complicated. Both required tuning expertise most people didn't have. You needed a distributor machine, timing lights, dyno time, and the knowledge to interpret what you were seeing. There had to be a better way. Chapter 3. Enter Jim McFarland, GM engineer. Enter Jim McFarland. This guy was a Pontiac engineer based in Warren, Michigan, working out of the tech center. He'd started at GM in 1971. Fresh out of Michigan State with a mechanical engineering degree. They stuck him in emissions compliance, which in the early 70s was the automotive equivalent of hell. His job was basically to make engines pass increasingly strict EPA regulations while keeping them running, not running well, just running. By the late 70s, McFarland had worked his way into the powertrain division, specifically the ignition systems group, and he was frustrated, really frustrated. Not the quiet, professional frustration of a guy who's disappointed with a project. The deep, burning frustration of an engineer who knows things could be better, but is being held back by bureaucracy and compromise. McFarland knew the HEI distributor, GM's high-energy ignition, was actually a brilliant piece of engineering. Introduced in 1975, it was one of the first mainstream electronic ignitions, revolutionary for its time. It had the coil built right into the distributor cap, eliminating external coils and all that wiring. It produced 40,000 volts compared to the 20,000 from old points ignitions. It was more reliable because there were no points to burn or adjust. The module replaced all those mechanical contact breakers that used to fail every 10,000 miles. The basic design was sound, really sound. GM's engineers had actually done something right. The problem wasn't the hardware. The problem was the advanced curve calibrations. They were strangled by emissions requirements, choked by corporate policy, neutered by the EPA. McFarland would sit in meetings watching other engineers present timing curves that made no sense from a performance or efficiency standpoint. When he'd ask why they were calibrating them that way, the answer was always the same. Because that's what passes the test. Not because it's optimal, not because it's best for the engine, because it passes the government tests. So, McFarland started experimenting. This wasn't approved, wasn't part of his job description. He'd take distributors home, modify them in his garage on nights and weekends, test them on his personal cars. His wife thought he'd lost his mind. The guy had a perfectly good job at GM, and he's spending his free time tearing apart distributors in his garage like some shade tree mechanic. He tried different springs, lighter ones, heavier ones, progressive rate springs. He tried different weights, drilling holes to reduce mass, adding material to increase it. He tried different vacuum advance canisters with various diaphragm rates. He was obsessed with finding the perfect advance curve, the curve Detroit should have been using all along. And here's what he discovered. The expensive aftermarket solutions were overthinking it, way overthinking it. MSD with their multiple spark discharge and fancy electronics. Mallory with their adjustable mechanical advance and billet components. Axel with their super coils and voltage boosters. They were all solving the wrong problem. They were adding complexity when the issue was calibration. The HEI didn't need more voltage or multiple sparks or electronic control. It just needed the advance curve it should have had from the factory. Chapter 4, the $12 revelation. The HEI distributor used 2 springs to control mechanical advance. A heavy primary spring and a lighter secondary spring working in tandem. The primary spring controlled initial advance, keeping timing from jumping too quickly right off idle. The secondary spring controlled how fast you got to total advance once the primary spring was overcome. It was a progressive system, designed to ease timing in gradually. GM had calibrated these springs to be progressive and slow, advancing timing gradually from idle all the way to redline. This was great for emissions testing, terrible for actual power. The stock primary spring was stiff, really stiff. It took significant RPM to overcome it. The secondary spring was only slightly lighter. Together, they created an advance curve that crawled from initial timing to total advance over about 3,000 RPM. Your engine would basically stumble along with inadequate timing for the first third of the power band, then slowly work its way up to something resembling optimal by the time you hit highway speed. By then, you'd already lost the race or missed the merge or given up trying to pass. McFarland figured out that if you drilled 3 small holes in the advance weights to reduce their mass by about 30%, swapped the primary spring for a lighter aftermarket spring that cost $4 from the GM parts counter, and slightly modified the stop bushings to limit total advance, you could create an advance curve that was faster, more aggressive, and actually better for both power and efficiency than anything GM or the aftermarket offered. The lighter weights meant less mass to swing outward, so they responded quicker to centrifugal force. The lighter spring meant they could start advancing earlier in the RPM range. The modified stops prevented over-advance that could cause detonation on pump gas. The entire modification cost $12 in parts. $12. $4 for the spring. $3 for a new set of stop bushings. $5 for the drill bit and some sandpaper to clean everything up. That's it. No special tools beyond a drill press, no exotic materials, no computer programming. Just basic mechanical modification that any competent mechanic could do in an hour. Here's where it gets interesting. McFarland didn't invent some radical new technology. He didn't add electronics or computers or anything complex. He just fixed GM's intentionally neutered calibration. The physics were simple, almost embarrassingly simple. Lighter weights responded faster to centrifugal force. Lighter springs allowed more advance at lower RPM. The modified stops prevented over-advance that could cause detonation. That's it. That's the whole secret. No magic, no exotic metallurgy, no aerospace-grade components. Just the calibration the HEI should have had from day one. But the results were insane. McFarland tested his modified distributor on a stock 1979 Pontiac Firebird Formula with a 400 cubic inch V8 stock. The car made about 220 horsepower at the wheels and ran mid-15-second quarter miles. Typical smog-era disappointment. With just the distributor mod, no other changes, no carb work, no headers, no cam, it made 247 horsepower and ran high 13-second quarters. 27 horsepower and over a second quicker from a $12 modification. Let that sink in. Chapter 5. The Technical Deep Dive. The technical explanation is actually pretty straightforward. Stock GM distributors in this area were calibrated to start advancing at around 1,000 RPM and reach full advance around 3,000 RPM. This meant that from idle to 1,000 RPM, you had almost no advance. Your engine was basically pinging along with terrible timing. Then from 1,000 to 3,000, the advance would creep up slowly. By the time you hit 3,000, where most engines make peak torque, you finally had optimal timing, but you'd lost all that low-end and mid-range power getting there. McFarland's modification changed the curve to start advancing at 600 RPM and reach full advance by 2,200 RPM. This meant your engine had proper timing across the entire power band. Off-idle performance improved dramatically because you actually had advance when you needed it. Mid-range torque increased because you weren't fighting a timing curve designed for emissions rather than physics. Top-end power improved because the engine was spending more time at optimal timing rather than slowly ramping up to it. The modification worked so well because it aligned the mechanical advance curve with what the engine actually needed, based on piston speed and flame front propagation. This is basic thermodynamics. You need to ignite the mixture early enough that peak cylinder pressure occurs at the right point after top dead center. Too early and you get detonation. Too late and you lose power. GM's stock curves were too conservative, designed to prevent detonation under worst-case conditions with the worst gas and the most carbon buildup. McFarland's curve was optimized for normal conditions with decent gas. The beauty of it was reliability. The expensive MSD and Mallory systems had boxes full of electronics that could fail. They had complicated wiring that could short out. They required precise installation. McFarland's mod was purely mechanical. Nothing to fail except the same springs and weights that were already in there. And because you weren't over-advancing the timing, you weren't increasing stress on the engine. If anything, the engine ran smoother and cooler because combustion was more efficient. Chapter 6. Word spreads underground. Word started spreading in late 1981. McFarland had shown the modification to a few fellow engineers and some friends who raced on weekends. They tried it. Holy hell, it worked. One guy put it in his Chevelle, picked up half a second in the quarter. Another guy put it in his GMC truck. Suddenly, his truck that struggled to tow up hills could pull like it had twice the engine. A third guy, the Trans Am driver from our opening story, started showing up at drag strips and embarrassing cars with expensive ignition systems. The racing community started paying attention. Drag racers are always looking for cheap power. $12 for 25 horsepower? Sign them up. But here's where it gets weird. When people asked McFarland about it, he'd explain the modification in detail. He never tried to patent it or profit from it. He was just a GM engineer who'd figured out how to make GM distributors work properly. He'd give people the spring part numbers, explain the drilling procedure, tell them exactly what to do. By early 1982, performance shops in Michigan and Ohio were offering the modification as a service. $25 labor plus the $12 spring kit. $37 total to outperform a $2,000 MSD system. Customers started requesting it specifically, the McFarland Distributor mod. That's what people called it. GM's parts department started getting orders for the specific springs McFarland recommended. Some counter guys caught on. They started keeping the springs in stock. A few dealership mechanics who raced on weekends started doing the modification on customer cars, usually without telling the service writers. Then, the aftermarket companies noticed, and they were not happy. If you're MSD selling $2,000 ignition systems, and some GM engineer is giving away a $12 modification that works better, that's a problem. MSD and Mallory both released white papers claiming that mechanical distributors couldn't match the performance of electronic ignitions. They emphasized the importance of multiple spark discharge and high voltage. They carefully avoided mentioning advanced curves because that's where their systems didn't actually have an advantage. Chapter 7. The suppression. GM's reaction was complicated. On one hand, they had an engineer who'd figured out how to make their distributors better. On the other hand, he'd basically proved that GM had been calibrating distributors wrong for years. And if they officially endorsed this modification, they'd be admitting their stock calibrations were garbage. Plus, there were warranty implications. If dealers started modifying distributors and something went wrong, who's liable? The hammer came down in mid-1982. GM issued an internal service bulletin, not a public recall or technical service bulletin that customers would see, an internal memo to dealerships. It essentially said, that modified distributors were not covered under warranty, and that dealers should not perform non-approved modifications. It didn't specifically mention McFarland, but everyone knew what it was about. The official justification was that modified advanced curves could cause detonation with low-octane fuel, potentially damaging engines. The real reason was corporate CYA. McFarland himself was quietly told to stop talking about the modification. He wasn't fired or disciplined officially, just a friendly conversation with his supervisor suggesting that maybe he should focus on approved projects. The message was clear. GM didn't want this getting bigger. They had relationships with aftermarket suppliers. They had warranty concerns. They had emission certifications to protect. A rogue engineer giving away free performance mods was not part of the plan, but you can't put the genie back in the bottle. By 1983, the modification was standard practice in certain circles. Drag racers knew about it. Hot rod shops offered it. Magazine articles started mentioning it, though usually without full details, because the magazines depended on advertising from companies like MSD. Carcraft ran a piece in 1984 called "The Distributor Mod GM Doesn't Want You to Know About." They didn't give McFarland's name, but they described the modification in detail. Chapter 8. The Cars That Proved It. The cars that proved it worked are legendary in certain communities. There was a 1978 Firebird Trans Am, owned by a guy named Rick Donahue in Cleveland. Stock 400, stock everything except the distributor mod. That car ran consistent 13.8-second quarters on street tires, with just the distributor. There's a video of it racing at Norwalk Raceway in 1983, beating a Camaro with a full MSD setup. The Camaro owner was so convinced Donahue was cheating that he protested to tech inspection. They pulled Donahue's distributor apart. Stock, HEI, with modified springs and weights. $12 model, legal. Another famous example was a 1980 Chevy Silverado owned by a farmer in Iowa named Dale Peterson. The truck had the 350 cubic inch small block, too gutless for towing. Peterson heard about the modification from a mechanic friend, did it himself in his barn. The transformation was dramatic. The truck that previously struggled to pull a fully loaded cattle trailer up hills suddenly had power to spare. Peterson put 300,000 miles on that truck, towing heavy loads constantly. The modified distributor never failed, never needed adjustment, just worked. There's a Pontiac Grand Prix from 1981 that's still running the McFarland mod today. It's owned by a collector in Florida who uses it as a daily driver. 428,000 miles. Original engine, original transmission, original distributor, with the $12 modification done in 1982. The owner, Jim Reynolds, swears the distributor is the reason the engine lasted so long. Better timing means more efficient combustion, less stress, lower temperatures. The engine runs like it has half the miles. The drag racing victories were numerous but rarely documented because this was the era before everyone had cameras at races. But old-timers remember the purple Trans Am that ran 11s on the street, the Malibu wagon that would blow the doors off Mustangs, the El Camino that won bracket racing championships 3 years running. All modified distributors, all $12 mods, embarrassing expensive systems. Chapter 9. Modern implications. Modern implications of this story are fascinating. Today, if you're restoring a late 70s or early 80s GM car, the McFarland modification is almost mandatory. The restoration community figured this out years ago. Companies like Summit Racing and JEGS sell spring kits specifically marketed for HEI distributor curve modification. They don't mention McFarland because GM never officially acknowledged him. But that's what they are. The modification still works perfectly on any GM vehicle with an HEI distributor from 1975 to 1995, and it works for the same reason it worked in 1982. The physics haven't changed. Engines still need proper advanced curves. Modern coil-on plug systems have essentially recreated what McFarland figured out with mechanical parts, using computers and sensors to optimize timing in real time. But for carbureted engines without computers, the mechanical solution is still the best solution. What's ironic is that GM eventually incorporated modified advanced curves into their performance distributors. The Corvette and Camaro, IROCZ in the mid-80s, got distributor calibrations that were much more aggressive than standard GM distributors. They weren't quite as aggressive as McFarland's modification, but they were moving in that direction. GM never credited McFarland, never admitted that their engineer had been right all along. They just quietly changed their calibrations and hoped nobody would notice. The aftermarket finally caught up in the 1990s. Companies started selling performance-calibrated, HES distributors with advanced curves similar to what McFarland had created. They charged $200 to $300 for distributors that had $20 worth of different springs and modified weights. The markup was insane, but people paid it because they didn't know you could do it yourself for 12 bucks. Conclusion. The lesson. The lessons here go beyond just ignition timing. This story is about how corporations suppress simple solutions because they complicate the business model. GM couldn't officially endorse the modification because it would expose their stock calibrations as inadequate. The aftermarket companies couldn't acknowledge it because it would destroy their market for expensive electronic systems. So everyone pretended it didn't exist, while quietly implementing similar solutions under different names. It's also about the difference between engineering for compliance versus engineering for performance. McFarland was a GM engineer, trained by GM, working at GM. He knew how to make distributors that passed emissions tests, but he also knew how to make them perform better. The company wanted the former, customers wanted the latter. McFarland gave customers what they wanted, and the company shut him down. Think about how many other simple solutions are out there, suppressed because they threaten someone's profit margins. How many cheap fixes exist that companies don't want you to know about because they'd rather sell you expensive replacements? The McFarland modification cost $12 and delivered better results than $2,000 systems. That ratio, that 167-to-1 advantage for the simple solution, should terrify any company selling complex, expensive products. The story also highlights something beautiful about mechanical systems. McFarland's modification was purely mechanical. Springs and weights, no electronics to fail, no software to corrupt, no wiring to short out. Just physics and metallurgy, and it worked flawlessly for hundreds of thousands of miles. In our modern world of electronic everything, there's something satisfying about a mechanical solution that just works. What happened to McFarland? He stayed at GM until retiring in 2003. He never got official recognition for the distributor modification, never got a bonus or promotion for it. In fact, it probably hurt his career because he'd embarrassed the company, but he didn't care. He'd done it because it was the right solution to the problem, because he was an engineer who cared about making things work properly, not about protecting corporate interests or aftermarket profit margins. There are still guys out there who learned the modification directly from McFarland in the early 80s. They're old now, in their 60s and 70s. But they remember. They remember when a GM engineer bucked the system and gave away a performance secret that the company and the aftermarket wanted buried. And they still do the modification on their cars and their friends' cars because it works, because it's simple, because it's right. The $12 distributor mod that destroyed expensive ignitions isn't just a story about ignition timing. It's a story about corporate priorities, about profit versus performance, about complexity versus simplicity. It's about how sometimes the best solutions are the ones nobody wants you to know about because they're too cheap, too simple, too effective. Every time someone installs a $2,000 ignition system on their classic GM car without knowing about the $12 modification that works better, McFarland's ghost probably sighs. Every time a restoration shop charges $500 for a performance distributor, that's just a stock HEI with different springs, he probably shakes his head. And every time someone discovers the modification and realizes they just got 25 horsepower for $12, he probably smiles. The next time someone tells you that you need to spend serious money for serious performance, remember the McFarland modification. Remember that sometimes the best solution is the simplest one. Remember that corporate interests and profit margins don't always align with what actually works best. And remember that somewhere out there, There's probably a simple $12 fix for whatever problem you're trying to solve with an expensive, complicated solution. Jim McFarland proved that genius plus garage could beat billions plus bureaucracy. He proved that one engineer with a drill and some springs could outperform entire companies with marketing budgets and engineering departments. He proved that sometimes the best way to fix a problem is to stop overthinking it and just fix the actual problem. The Trans Am that started this story, the one that kept winning at Orange County International Raceway, it's still around. The owner sold it in 1987, and it changed hands several times. Today it sits in a private collection in Arizona. The Distributor still has McFarland's modification. 40+ years later, $12 in parts, still making more power than systems costing 100 times as much. That's not just a modification, that's a legacy.